I'm going to help you learn to solve quadratic equations. This is a fairly large topic with a lot of different pieces, so this is kind of our roadmap. If you want to solve a quadratic equation, there's four main methods: factoring, square root property, completing the square, and the quadratic formula. Now within those four methods, the first one, factoring, there's four different kinds of factoring. And then once you get the quadratic expression factored, you use the zero product property. So that's where we're going to start. We're going to start with factoring, and the first type that we're going to look at is using the difference of two squares formula to factor your quadratic. In order to factor a difference of two squares, you're going to be using a formula, and this is your formula. X squared minus y squared is equal to x plus y, x minus y. A formula is just kind of an if-then proposition. If you have this, then you can do that. So first let's translate this formula into English. X squared represents any perfect square, as does y squared. That's any perfect square. So first we need to know what are perfect squares. Well, perfect squares are numbers that when you take the square root of them, you get a whole number. So for example, perfect squares would be 1 and 4 and 9 and 16 and 25, 36, and so forth. Because when I take the square root of these numbers, I get a whole number. The square root of 1 is 1. The square root of 4 is 2. Okay? So here are the perfect squares. Now when I have a y squared here and then a y over here, this y represents the square root of it. So let's just look at how this would apply to, say, x squared minus 16. First you check it. You have a perfect square, you have a perfect square, and in order to be a difference, you've got to have a minus sign. You cannot do it with a plus, you've got to have a minus. So x squared minus 16 would factor into x plus 4, x minus 4. And that's all there is to it. So let's look at some other examples. If I had a squared minus 25, I would use the formula to be a plus 5, a minus 5. If I had b squared minus 49, I would factor that into b plus 7, b minus 7. It's just that simple. Now, let's look at some problems that have a little bit of a catch to them. These two problems have a larger exponent than 2, so what do you do about that? Well, anytime you have an exponent that is even, 2, 4, 6, 8, 10, the square root of it is half that. So to take the square root of x to the 4th, that's just going to be x squared plus 5, and then x squared minus 5. Here I've got x to the 8th. Well, half of that is going to be x to the 4th plus 3, x to the 4th minus 3. And anytime you factor these, you can always go back and FOIL your two binomials, use the FOIL method on them, and you should get your original expression. You're not changing the value, you're just changing the look of it. Okay, let's look at these. b squared plus 49. This is a perfect square, and this is a perfect square. The problem is, this is a plus sign. You cannot factor a binomial that has a plus sign in the middle with the difference of two squares formula. It has to be a minus. So you could just put not possible on this one. Okay? This one has a perfect square. It does have a minus sign, but 10 is not a perfect square. So once again, you're just going to put prime, not possible, can't factor. Okay? Alright, just a couple more and you'll have this. Okay, you look at this problem and you think, neither one of those are perfect squares, so I can't factor. But the rule about factoring is you always look for a greatest common factor first, no matter what. A lot of times there's just not one, but you always need to look for one because it could lead you to eliminating something that shouldn't be eliminated. Now, the greatest common factor between these two numbers is 3. And when I factor that out, I get x squared minus 25. This is a difference of two squares and can be factored by x plus 5, x minus 5. So, always look for that greatest common factor first. Another rule is, you never stop factoring until you're all factored out. You always check your result to be sure you can't go any further. On this one, the difference of two squares would be x squared plus 1, x squared minus 1. Now when I look at this second factor, I see that I still have a difference of two squares. So you want to continue on. Now the first factor won't change because this is a sum. Even though it's two perfect squares, you can't factor it. But this, I can break it on down into x plus 1, x minus 1. So that would be your final answer there. One more, and this one's a doozy. Okay, it doesn't look like a difference of two squares, but first you want to take out any greatest common factors. I see that this is an even number and this is a 2, so I know that 2 will go into both of them. Now I also see that this has x to the 5th, but this has an x, so I can take out an x that's common as well. Now when I pull these factors out, when I divide them out, I'm going to be left with x to the 4th minus 81. Okay, x to the 4th minus 81. This is the difference of two squares. Now don't lose your 2x. Keep bringing it down. This will factor into x squared plus 9, x squared minus 9. Now, what do you see happened here? You still have a difference of two squares, so you have to keep factoring. Don't lose your 2x. Don't lose your x squared plus 9. And then factor this into x plus 3, x minus 3. Okay? That is all there is to factoring the first type, which is a binomial. You're going to count your terms, 1, 2. If you've got two terms, difference of two squares is your only option for factoring that quadratic. I'm going to drop a link down below to a worksheet that you can download if you want to practice these some. And if you have any questions about the problems on the worksheet, just drop me a comment below. And keep checking back because I'm going to do the whole series on these quadratics. So when I get through, you'll know how to factor any quadratic and solve any quadratic equation. Okay? Thanks for watching. Have a great day.